For respiratory histology, we were able to look at the cardiovascular histology, neurohistology, basic histologies last time. So for now, we are looking at the histological pathway that will lead to us able to absorb in air, and then how the interchange would be done. That is respiratory histology. There is one good thing I have to let you. So the very first thing is, before I even start talking about the respiratory histology, it was good we've done the respiratory system in anatomy. So now whatever I will talk about, you will be able to what? Understand. I hope you can see the slide. So yes, for now, with the respiratory system, as I said, we have conducting part and then the respiratory part. Okay. Now the conducting part begins from the nostrils all the way to the terminal bronchiole. And then the respiratory part begins from the respiratory bronchiole all the way to the alveolar. So for the terminal bronchiole, what happens is that when you begin to move from the trachea all the way to the alveolar, there is one thing you will have to take note of. That one thing that you have to take note of, you can come and sit here. Note of is the gross structure of the respiratory system, which I'm going to demonstrate on the whiteboard. So the very first thing is, every organ, as I said, will be classified on a basic gross morphology. So the basic gross morphology of the respiratory system, you have something like this, a round structure. Okay, this is how it is developed, a round structure. After the round structure, you have another structure in there, okay? So there are three basic structures that make up the respiratory histology. So as you move from the nose to the alveoli, the very first thing is what is happening to, what are the changes that is occurring in the red one? What are the changes that is occurring in the white one? And what are the changes that is occurring in the black one? If you know the reasons pertaining to this, then you will be able to understand your respiratory histology. Now, the gross morphology is that the red one that you see, the respiratory histology is placed in what? Three main parts. You see the mucosa, that is the red one. And then you see the white space to be the the submucosa. And then you see the black one as the adventitia. So the respiratory histology has three main parts: mucosa, submucosa, and then the adventitia. If you raise your hands and I don't call you in, it doesn't mean I won't call you. I'll call you later. I've seen you. I'll call you later, but we need to get somewhere, then I can attend to you. So for the respiratory histology now, what we have to note is that you have to know what is happening to the mucosa as you drop from the trachea to the alveoli. Then what is happening to the submucosa? The submucosa, is it that the trachea is the cartilage, the fibers? What is happening to them? So you would have to know the differential drop downs from the top to the down, okay, from the trachea level. So for instance, what I'm trying to say is that you have, this is the respiratory system. So you have the bifurcation, and then this also bifurcates further. This also bifurcates further. So as I move down from the trachea to the bronchus, what is happening to the mucosa? What is happening to the submucosa? What is happening to the muscularis? That's all that we are going to start study. And then when I move from the primary bronchus to the secondary bronchus, which is this one, what is happening to the mucosa? From what is happening to the submucosa? What is happening to the muscularis? And then the adventitia. Those are the basic things that we are going to study. And when you know these things, then you are very good to go in what? Functional histology of the respiratory system. So now let's go back to the slide, and then we can conceptualize what I was talking about earlier. So as you can see, can you see the pointer? Can you see the pointer? Okay, so the trachea all the way to the terminal bronchi is the conducting part. And then the respiratory bronchi to the alveolar is the gaseous exchange or the respiratory part of the respiratory system. So now we are going to begin the main histology. So we will be taking the trachea, then we'll come to the bronchus. Under the bronchus, you look at the primary bronchus, the secondary bronchus, and then the tertiary bronchus. Then we will move to the bronchiole, and then we will move to the lungs. Okay. So the other thing I'm also trying to do, because the videos are so big that I cannot upload on the LMS, I'm creating a YouTube channel. Then I'll give you the links. I'm still working on that, so that you can just click on the links and then you watch. That's one way I can do that for you. So the videos will come. But when those who have not been visiting the LMS, please make sure you visit there, because a lot of things are happening there. I gave a surprise quiz. Nobody attempted it. I gave a surprise quiz. Nobody saw it. So I was just trying to see those who visit the LMS. But unfortunately, and fortunately for some of us, nobody attempted it. You were fortunate because nobody attempted it. And unfortunate also nobody attempted it on my part. So please make sure you visit the LMS regularly. So taking the trachea, as I was saying, we have the mucosa, all this side, that's the mucosa. So this part, and then this mucosa is made up of 3 parts, okay? Basically, you called me, so my network went off. So let's continue. These are some of the reasons why I prefer the dawn lectures. So coming here, this is the mucosa, or this one. The mucosa is made up of the epithelium and then the lamina propria. So normally what happens is that, let me go back to the whiteboard. What happens is that when you take the mucosa, I'm going back to the whiteboard. The mucosa will always be made up of 3 main parts. Let's say when we take the thing, this is the mucosa, which is the inner one. It will be made up of basically 3 parts for almost all organs. At some will be 2, but you have 3 for some. But basically you see 2. If you don't see any at all, you see 2, which is like this. So that red thing I drew earlier, the inner one, is made up of these 3 main things. So it has an inner part, which is the epithelium, and then the space between the inner part, which is the lamina propria. The lamina propria is actually a connective tissue. Lamina propria is actually a connective tissue. And then you have the outer one, which it will be the muscularis mucosa. The muscularis mucosa. So you have the inner one, which is with the epithelium, followed by a connective tissue, which we call the lamina propria, and then the outer one, which is what? A muscularis mucosa. But in the case of the respiratory system, we do not usually see the muscularis mucosa. Okay, we do not usually see the muscularis mucosa. So for now, that is what we will be saying. So for the epithelium, when we come to the respiratory system, going back to this, the epithelium, which we can see over here, is always a pseudostratified columnar ciliated epithelium. So I will be magnifying this as we go along. So this is a pseudostratified columnar ciliated epithelium. Okay, and then following this, you can see this side. you can see that there are some small blood vessels in there. So far as you begin to see a blood vessel, it tells you it is a connective tissue. So this is the lamina, okay? This one, the lamina propria, which will follow the epithelium. So that lamina propria is actually a connective tissue, and the type of connective tissue you see there is a loose areolar connective tissue. Loose areolar connective tissue. Then the loose areolar connective tissue that you see now, after it, you have the submucosa, okay? In the submucosa, you have some seromucous tracheal glands. Seromucous. When we say seromucous, it means that they can secrete both serous secretions that are watery secretions and also mucous secretions that are the phlegms. So, and then one beautiful thing is that within the epithelia, within the pseudostratified epithelia, you also see goblet cells. You also see goblet cells. So coming to the submucosa, you have mucous glands. Then when we move to the adventitia, the main thing you see in the adventitia is the haline cartilage. This is the cartilage, which is in form of C rings. They are not complete, okay? They are in form of C rings so that they will continue to open up the trachea. So the trachea is never collapsed. The day your trachea will get collapsed, it means that we should take a 6 feet for your burial. So the C rings are there so that it will keep the trachea always open. Then where we do not have the trachea, the trachealis muscle, okay, the trachealis muscle will continue to join the trachea. So this is the trachea, and then this is the trachealis muscle. Then the outermost portion of the adventitia, you begin to see blood vessel and other stuff. So this is the histological presentation of the trachea. So taking the mucosa more into place, this is the mucosa, and then this is the submucosa, and then this is the adventitia. Before the adventitia, we will see the cartilaginous layer. This is the cartilaginous layer, okay? Cartilage under H&E is not stained. That is how you see there. So the mucosa, that thicker part of the mucosa is the epithelium, which is made up of pseudostratified columnar ciliated epithelium. And then this one here is the propria. So magnifying this better, we can see from here, this is actually the basement membrane of the epithelia lining. This part is the lamina propria. So from here all the way to the top is the pseudostratified columnar epithelia, which is ciliated. So these whitish things that you see are the goblet cells I was talking about, which will secrete mucus secretions. So when we take the mucosa, the epithelium, as I said, then under the cell types we can see, I can ask you to describe the morphological organization of the mucosa, okay, of the respiratory, the trachea. That alone, I can give 15 marks. That means you need to tell me all these things I'm going to do. So the cells we can see here first are the pseudostratified columnar cells, which are ciliated. Then we can have the goblet cells. We can have the basal cells, which are almost down here, which will what? Produce other cells. The granular cells, we cannot see them here, okay? Then in the trachea, we will not see the surfactant secretions there unless we are getting a bit closer to the bronchus. Then in the lamina propria, all you see, as you can see, blood vessel capillary. So within the blood vessels, we can see some lymphocytes, we can see some mast cells. The mast cells are there to release histamine. Okay, so the mast cells will release histamine. And that histamine is responsible for inflammation. It's responsible for inflammation. So this is just to show how the pseudostratified columnar ciliated cells are, okay? See that each of the cell begins from the basement membrane. And then you can see the cilia on top over here. And then this is the goblet cells, which will secrete the mucus. Just to show more of it. It's just to show more of the secretion, the epithelium. So this is your connective, the first connective tissue, which is your lamina propria. These are your seromucous glands. These are your seromucous glands. What you are seeing here is the cartilaginous cells. So showing you a wider view, you can see the epithelium. You can see the nuclei, which is deceiving us as if it was having more than one layer. Then we can see the lamina propria below it. This is a blood vessel here. Then when we take the submucosa, which is from here all the way to this place, the main thing, the submucosa is made up of loose connective tissue. Then we have mixed glands. These mixed glands are seromucous because the serous secretions and mucous secretions, they are termed as seromucous glands. And then we can, within the submucosa, because it's a connective tissue, you know surely there will be blood vessel. Then I told you the cartilage will also veer into the subconnective tissue because cartilage is a special connective tissue. Then where the cartilage doesn't end, or at the ending point of the cartilage, the trachealis muscle will continue. Let me just try to demonstrate that on the whiteboard. So for instance, if this is the trachealis muscle, so if this is the trachea always end in this way. That is the cartilage within the trachea. We always have these C rings. Then at the end part where we do not have the cartilage, the trachealis muscle will end there. So what happens is that as you descend the respiratory tract, the trachea diminishes. The amount of trachea diminishes, and then the muscle begins to increase. That is one key thing you always need to put in your mind. As we descend from the trachea all the way to the bronchus or the bronchiole, the amount of trachea diminishes, and then amount of the muscle increases. That's a smooth muscle. So let's continue with the slide. So you can see the cartilage is a C-haline cartilage, okay? And then the adventitia is actually a fibrous connective tissue. Remember, fibrous connective tissue, okay? Fibrous connective. So you can see this is the cartilage that is ending here, and then this is the end part of the C. And then you can see the trachealis muscle or the smooth muscle now ending that part for it, okay? So that we can have a distinction between the adventitia and then the submucosa. So who can tell me what this is? These small round things, what are they? These ones that I'm showing, what are they? This one, what are they? Yes, if you know, you raise your hands. What are they? Yes, Stacy.
Sir, please, blood vessels.
That's beautiful. Then what about these ones? What is it? They are also round. Who would want to try? Anybody? Let me see. Richmond.
So the glands.
What type of glands are they?
Seromucous.
Seromucous glands. Seromucous. That's good. It means you guys are following. One beautiful thing about this is that if you take your functional histology very seriously, you will never have issues with your histopathology. So you take your functional history seriously. The books you have now, the guide workbooks you have now, when it is time for histopathology, you will need them the most. You will need them the most. So please take key concern about your functional histology. If I'm the one to take you the histopath, fine. But if I'm not to fine, you must know that these things are there for you at any time. So taking a sectional view, you can now see the epithelial lining over here, and then we can see the cilia on top. Then from all here to this part, you have the what? The submucosa, and then you can see your seromucous glands. So what is the, oh, the answer is here. I wanted to. So normally what you realize is that a gland will always have a secretory portion and then a ductal portion, because these are all exocrine glands. So whenever you see the secretory portion, you will not see much hole inside it. But the ductal portion, you will see a smaller hole, which looks more of like a blood vessel, but it is thicker than a blood vessel. And then you see a hole, a bigger hole inside. So when you see this is the secretory part of the seromucous glands. So I can ask that question, especially in the practical exam, send it. What is this? This is the secretory of the seromucous glands, and this is the tactile part of seromucous glands. So taking a cross-sectional view or transverse view of a human throat, let me say, or a throat of an organism. The esophagus lies posterior to the trachea. Okay, so you can see this is the incomplete C ring, another one over here, and then this is the inner part, which is what? So who can tell me what this part is? Who can tell me what this part is? Let me see. Yes, Winifred. Yes, Winifred.
So the mucosa.
Yeah, the mucosa. But which part of the mucosa is this? Yes, Winifred again.
So the epithelium.
But now, if you are going to name an epithelium, you have to be specific.
Stratified ciliated columnar epithelium.
Stratified columnar ciliated epithelium. Okay. Is she correct?
Yes.
Yes.
Are you sure she's not lying?
Yes.
Okay. So now what is this part? This part that I'm showing. What is this? What is that part? What is that part? Nobody.
Is it the lamina propria?
Lamina propria. Okay, someone says lamina propria. Is the person correct? That's
You will take it like
that's the submucosa. Now, if you want to see the lamina propria, do you see the epithelium? Can you see a very small whiter part before the main whiter part over here? Can you see it?
so we can't see you.
Oh, you can't see it. Okay. So after the epithelium, if you actually enlarge this, you see that there's a smaller whiter part. Then after that, there is a black thing before the main white one. That is the lamina propria. But this one is the submucosa. What about this? What is this?
Haline cartilage.
You said?
Haline cartilage.
Haline cartilage.
Cartilage.
That is very beautiful. You guys are good. Okay. Then what is this?
So the pointer is not moving.
Are you sure? Or is it only your screen? Can you see? The network. Yes, Stella.
Muscularis mucosa.
Oh, this place, that's no muscularis mucosa. Or you are out. Look at it again. Yes, but what is the name of that connective tissue? Fibrous connective tissue. But what is the general name? Yes, Bruce.
Say the mucosa.
No, how can the mucosa be here, Bruce? After cartilage, you are telling me mucosa. Adventitia. Okay, that is the adventitia. The adventitia. Yes, I told you we have three major layers. Okay, so you have the mucosa, which is layer 1, which is inner, followed by the submucosa. Then you have the adventitia. But between the submucosa and then the adventitia, you also have the cartilaginous layer and the muscularis layer. Okay, let us continue. And what you see here is the esophagus. Okay, the esophagus. So this is just to demonstrate more on things. So let's look at the bronchus. So we are looking at the primary bronchus. So the primary bronchus has the same organization just like the trachea. The only difference is that the cartilage are irregularly arranged. The cartilage in the cartilaginous layer, they are irregularly arranged. You don't really see that C-shaped cartilage. Okay, you don't really see that C-shaped cartilage in there as you see in the trachea. Then it also has the same word, epithelia. Okay, it also has the same epithelia. That is for the primary bronchus, the same thing. Okay, but when you come to the secondary, you have irregularly arranged cartilage. So when you take the primary bronchus, as at now, you know the difference between the primary bronchus and the secondary bronchus, right? Which one is the primary bronchus? Which one is the primary bronchus?
The same as the trachea.
No. Okay, I'm going to draw something on the whiteboard. I want you to show me which is the primary bronchus. So you have something like this. And then I can continue. Continue. (23) of branching. Let me just end here. Which of this whole thing is the primary bronchus? I used color demarcation, so just tell me the color.
Red one.
The
Red one.
The red one is the primary bronchus. So what is the blue one?
The secondary bronchus.
The green one. Tertiary bronchus. So what is the yellow one?
The trachea.
You guys are okay. So now let's go back to the slides. So what I'm saying is that when we take the bronchus, the principal or the primary bronchus, the organization is just like the trachea, C-ring, cartilage, smooth muscle. The organization is just like that. But when we come to the secondary bronchus, the trachea, the main difference you see is that the trachea is irregularly arranged in the cartilage. Sorry, the cartilage is irregularly arranged in the cartilaginous layer. So this is the cartilage in the cartilaginous layer. So the cartilage is irregularly arranged. Give me 1 minute to plug in my thing. So looking at the bronchus, what we are seeing now is more of the secondary bronchus, okay? That's the secondary bronchus. But when you take the mucosa, you see that the epithelia is still the same. Pseudostratified ciliated columnar epithelium, okay? So you see that the pseudostratified columnar ciliated epithelium is there. But when you move from the tertiary, secondary bronchus to the tertiary bronchus, something beautifully changes. Something changes, okay, beautifully. What happens is that you have a change in the epithelium. Instead of pseudostratified ciliated epithelium, pseudostratified columnar ciliated epithelium, you now have simple columnar epithelium. I hope you are getting the difference. So the what is the difference in between the mucosa of a secondary bronchus and then a tertiary bronchus? The difference in the mucosa, you pay attention to the question, the mucosa. So if you go and tell me patches of cartilage, that one is not in the mucosa, so you are wrong. The only difference, the differences you see will always happen in the cartilaginous layer, the muscularis, and then the epithelium, and then the type of connective tissue. So there is a change from pseudostratified to what? Simple columnar. And then the irregularly arranged hairline cartilage, you don't see that, but you see patches of cartilage. Patches of cartilages, okay? You only see patches of cartilages. So this is all that I've been trying to explain. So changes as bronchus become smaller. Cartilages become irregular and smaller. And then when you reach the bronchiole, you don't have any cartilage at all. The muscle will also increase as the bronchi becomes smaller. Okay. So normally the spasms of these muscles bring difficulty in breathing. So when you are asthmatic, okay, and then you are beginning to secrete more mucus or something gets into the smaller regions of the bronchiole, this is when you begin to have those spasms, which can cause a lot of problems, okay? And then you can see epithelia will also be changing from pseudostratified ciliated columnar to simple columnar. And then that simple columnar also becomes non-ciliated columnar. So in the tertiary bronchus, you have what? Simple columnar ciliated. Then when we move to the terminal bronchiole, we will now have non-ciliated columnar. These are the things you should be taking note of. Okay. And then later it becomes cuboidal in the respiratory bronchiole. And then in the alveolar, it becomes what? Squamous. So going back to the whiteboard. Going back to the whiteboard, what I mean here is you have this, for instance, the epithelium will be pseudostratified columnar ciliated. And then here it is still the same thing. But when you come here, you have simple columnar, okay, ciliated. Here it will be simple columnar ciliated, okay. But when you begin to move down, it changes from simple columnar ciliated simple columnar non-ciliated. Then when you move to the terminal bronchiole, it becomes what? Simple cuboidal. Simple cuboidal. Then when you reach the alveolar, the respiratory, it becomes what? Simple squamous. So that is how it will be changing so that diffusion can happen. Okay, diffusion can happen. Let's go back to the whiteboard. Sorry, the So terminal bronchiole, you can see columnar epithelium. Here you don't have any cartilage. The smooth muscle will increase. Then clara cells are present. Go and look for the function of the clara cells. Okay, but when we reach the respiratory bronchiole, what happens is that we shouldn't be seeing columnar epithelium. We will now, it will change from columnar to cuboidal. I've explained that. One beautiful thing that the respiratory, when you read the respiratory part, is that there should be no mucous glands. So there should be no goblet cell or anything. The reason being that this place is so small. And then when you begin to have mucus in there, it will obstruct the movement of air into the what? The alveolar. And that becomes very problematic. So this is how you look at the histology when it comes here. So at this terminal bronchi, you are expecting to see simple columns which are non-ciliated. They are not ciliated. Okay, this is the respiratory. So from here, it will now move here. So you begin to see that this thickness is decreasing. At this part. This thickness, which is here, is actually decreasing at this part. Then here it becomes flattened. This is the alveolar duct. Okay. So it tells you here it is now simple squamous. So here I'm having simple columnar. I'll now have simple cuboid. And then I have simple squamous here. All these whitish parts you are seeing are alveolar sacs. They are alveolar sacs. So this is the gross representation of the lungs. So looking at this is the, yes, Joshua. Can you ask your question?
So the cursor was not moving, so I couldn't see anything.
And this one there, I'm sorry, is the network because it has been moving throughout. I'm very sorry for that. Okay. So let's continue. So this that we are seeing bronchiole, okay, we are seeing simple cuboidal epithelium, okay. We are seeing simple cuboidal epithelium. But when we come to the alveolar, you only see simple squamous, okay. So let's look at the bronchiole. So this is the bronchus. This is the bronchus, and then this is the bronchiole. Now look at, you are having patches of cartilages here, but here you don't see any cartilage. You only have the muscularis. Here you are seeing patches of what? Cartilages. That's one beautiful thing. And then also there is a change in the mucosa. The change in the mucosa. That is the comparison between the A and then the C. So all these whitish things that you see, that alveolar. So if I point on any dark thing here, it means that I'm asking for the type of epithelium, and that is simple squamous epithelium. Okay, and then this is an artery. So this is where the gaseous exchange will happen between this one and then this one, the capillary. Okay, and then the alveoli. So this is just to show us the gross presentation of the lungs. Then, so this is continuing with the bronchus. So when you get home, you can actually look at these ones. Okay. I hope I've already uploaded these slides or the LMS. They are already there. So make sure you download or you go there to watch them. So we've already discussed the difference between the bronchi and the bronchioles. So that is what we are seeing here. So in the bronchioles, we don't see any gland, no cartilage, no cell. We have smooth muscle layer, clara cells are present, and many elastic fibers. I can ask you to give me the histological difference between the bronchiole and then the bronchus. Then for this part, so this is showing us the terminal bronchiole. To show it better, you can see the smooth muscle layer here. The smooth muscle layer here, okay? And so who can tell me the type of epithelia that is here? This is a put the person in the waiting room or remove the person. That's all. So this, who can tell me the type of epithelia that is here? This is a terminal bronchiole. Who can tell me? You see, one beautiful thing you also have to notice that at the tracheus region, you will not see these things. When you are not seeing these things, it tells you that you are not nearer to the lungs or the alveoli. These are the alveoli. So when you see something round with muscle and then things here, it tells you are looking at the terminal bronchiole. Okay. From the terminal bronchiole, you go to the respiratory bronchiole. So go and look for this. These are some examinable questions. So it's just a similar thing that is here. Okay. This is the epithelial lining. This is the epithelial lining. You can see that it's just a simple epithelium. So what is it? Simple columnar epithelium. This is a simple columnar epithelium. When you come to the respiratory, you will see, but this is non-ciliated. This is what? Non-ciliated. That is one key thing you also have to take note of. This one, you can see they are just squamous cells, flattened type of squamous cells. And then between this one, you can see those red things. Okay, go and look out for what those red things are. Okay, don't tell me it's the blood. But this one is actually blood inside it. Those red things here, some can be capillary filled with blood, some can be clara cells, especially the dark ones. So this is just to demonstrate from the terminal bronchiole. That is from your tertiary bronchiole, you come to your terminal bronchiole. Then from the terminal bronchiole, now come to the alveolar. Sorry, the respiratory bronchiole. Then the respiratory bronchiole will give branches to the alveolar sac, which is connected by the alveolar duct. So this part is respiratory bronchiole, and this is your alveolar sacs and alveolar duct. So this is just to show, I'm just bringing more pictures, okay? So these are different states, okay? So this is your alveoli with your simple squamous epithelium. This is actually what your alveoli duct, okay? The respiratory bronchiole, which is having some smooth muscles in there. So here you don't expect to see any goblet cell, any form of. So this is just to give us the differences between from trachea to respiratory bronchiole. Very simple. I've made it very simple here for you. So make sure you take time to look at it. So when you see it from +3 and it is because then it tells you that, for instance, the goblet cells are more in the trachea. As you come to the bronchus, they reduce. Tertiary bronchus, they are gone. Bronchiole becomes small. Respiratory bronchiole, you see it. So that's the meaning of those plus. If it begins from smaller to higher, then it tells you that it is, for instance, look at the muscularis. So the muscularis mucosae, for instance, increases as you move from the top to the down. Okay, as you move from the top to the down. So these are just to tell you the type of cells we will see within the epithelia, the submucosa, and then the adventitia. Just few notes on them. So when you look at this picture, this is the trachea, this is the primary bronchus at the left part, and then the right part. So we are cutting this small portion, and that is what we are expanding here. Now, this small portion that we are expanding here is having the what? The respiratory bronchiole. This is the terminal bronchiole, which give rise to respiratory bronchiole, which attach to the alveolar duct and sac. These things are the alveoli, okay? And then the whole thing is the alveolar sac. Now I'm cutting this small portion and then I'm showing it here. Now when we take here, we have a lot of cell types we can see inside here. We have the macrophage in here. This is the blood vessel. So you can see oxygen diffusing into the blood vessel and carbon dioxide coming back here. Then we can have the type 1 pneumocytic cell, type 2 pneumocytic cell. Okay, these are the type 2 pneumocytic cell which are found at the border. Okay, if I were you, I'll go and start looking at what these type 2 pneumocytic cells will do. The type 1 pneumocytic cells, what are they? What type of epithelia that is found there? Okay, so this is the epithelium I'm talking about. You can see the simple cuboidal epithelium, and then here you can see that it's just a squamous epithelium. So we've already seen this. This is the alveoli. These are the respiratory bronchiole. So looking at the alveoli, we said we have about 200 million in a normal lung. So that is why the least amount of air you breathe, you will have what? You will be able to utilize that air very, very, very well. Okay. So looking at the type of cells that we can find in the alveoli, we have the type 1 pneumocytic cell, type 2 pneumocytic cell, macrophages or dust cell. So the type 1, they actually make the alveoli, that's the simple squamous epithelium. They make up the boundaries of the alveoli, and then they are also involved in the formation of blood-air barrier. Blood-air barrier. Then, so this is the type 1 pneumocytic cells, okay? They will kind of what? Simple squamous epithelium. Then for the type 2 pneumocytic cell, they are also known as the septa cells. They are round, more round, and they are not simple squamous, but they are a bit of cuboidal epithelium with some form of microvilli, okay? With some form of microvilli, okay? And then, and there should be a reason why there should be microvilli here. We should think about why microvilli, and you know what microvilli is, the function it is directed towards to. So the question is why microvilli? I can ask you, why do we have microvilli on the type 2 pneumocytic cells in the what? A respiratory bronchiole. And then there is one thing these type 2 pneumocytic cells do, produce the production of the pulmonary surfactant. Okay, the fluid that is secreted to spread over the alveolar surface. What does it do? What does that surfactant, what does it do? It is here. They are bactericidal liquid. So that means even if the air gets to that level and then there are still some notorious bacteria inside, the surfactant will take care of them. Bacteria will go to destroy if it only does something we call immunological evasion. They are able to integrate themselves into some of the cells that the T cytotoxic cells cannot see them. Okay, and then that happens. When that happens, we don't have our type 2 pneumocytic cells which are producing the surfactant to do justice to them. So the type 2 pneumocytic cells also would replace damaged cells. Okay, so looking at this picture, this is the lumen of the capillary. This is the endothelium, which is made up of what? Simple squamous epithelia. This is the type 2 pneumocytic cells. And this is the type 1 pneumocytic cell. This is the alveoli. So it is across this membrane that you have exchange of oxygen and then carbon dioxide. This is the type 2 pneumocytic cell. That does the secretion of the surfactant and then replaceal of what? All other types of cell. Yes. Come closer so that they can hear. Okay, someone wants to ask question. After that, Stella, you can ask your question. So,
Sir, please.
Stella, wait. Someone is asking question.
After the type 2 epithelium has produced the surfactants.
The type 2 pneumocytic cell.
Yeah, I want to know where they are stored. Is it the
Okay, the surfactant is stored all across the alveoli. Across the alveoli. Okay, so they are also involved together with the type 1 in the blood-brain barrier. Sorry, the blood-air barrier. You know this is the alveoli, so there's air inside here. The air you inhale will be in here. And then this is the blood where you have the diffusion across. So the surfactant is released. This produces the surfactant. So it is released into this yellow part. Okay. So that yellow part will surround the blood capillary. Okay. And then this one. So that it will also form part of the blood air barrier. So whatever bacteria that is in here and is able to evade here or vice versa, the surfactant is able to do justice to it.
does it have any connection with the laminar?
The laminar bodies. Are you talking about the propria?
See, I learned that sometimes the surfactants are being stored in the laminar. I just wanted to know if it has some connections.
Oh yes, it's not only produced in the alveolar state. At times you always go to the respiratory bronchial state. So those things in the mucosa, they surround the mucosa. That is all. It is within the mucosa that you can see this. Yeah. Yes, Stella.
Hello.
Yes, I can hear you.
And my problem has been rectified. Initially, when you were mentioning the type 1 epithelium and all those things, I wasn't seeing it. I was only seeing the previous slide there.
Oh, okay. Sorry.
Yeah, until it changed.
Okay, sorry. So this is showing us. So let's look at this carefully. The A means we are in the alveoli. The C means the capillary. II means type 2 pneumocytic cell. I means type 1 pneumocytic cell. Okay. So this is just to show us how when you take a cross section or a histological section through the alveolar duct, this is what you should be saying. Okay. And then telling us how blood quickly. So there are a lot of blood vessels. The lung is one of the most vascularized organ in the body, highly vascularized, so that the little air that comes into the alveoli can be utilized. Take key note about these slides. I don't joke with this particular slide. So I've spoken about the pulmonary surfactants already. One thing you also have to note is that it's constantly renewed, and then the compositions are phospholipids, proteins, and glycosaminoglycans. Aside having bactericidal function, they also reduce the tension at the surface of the alveoli and prevent the collapse of the alveoli during exhalation. When the alveoli collapse, then that means that you are going to have problems. So the surfactant will make sure that these things are not there. And then they also remove from the surface type 1, they are removed from the surface by type 1 pneumocytic cells and some macrophages that are there. I already spoke about the blood-air barrier, which is actually made mainly by the type 1 pneumocytic cell, mainly a thin layer made of type 1 lymphocytic cell, which also have what? A surfactant, I said that already. And then you also have some capillary, which is also there of the blood vessels. Okay, so I can also ask you to define or describe the histological presentation of the blood-air barrier in the respiratory system. So let's look at some form of what? Respiratory embryology. So in utero, by 25 to 36 weeks, you are actually having this, these are your capillaries, okay, that are being formed. And this is your respiratory bronchiole. You can see the respiratory bronchiole having what? Simple cuboidal epithelium, which at this time are not even microvillated, because in utero, the lungs are infunctional. The lungs are infunctional. So this is actually forming the terminal sacs. This eventually will develop into the alveoli or the alveolar sacs and duct. So as it is developing, then these cells, look at it. Look at how the cells are looking right here. These cells over here will begin to lose their what? Cytoplasm and become flattened. The cuboidal cells will begin to lose their cytoplasm and become flattened. And then from there, it will change from what? So until birth, you are not having these things happening. And then the capillaries also begin to become more. And then they will have their attachment to the simple squamous epithelium. So this is now going to develop into the alveolus or the alveoli, okay? And then the blood vessels will also kind of what? Contact it, and then we begin to have type 2 pneumocytic cells also coming in to form what? Together with this type 1. So these are the type 1 pneumocytic cells, which will come together with some of the bright borders to form the blood-air barrier. So this is the histogenesis of the lungs and then the formation of the blood-air barrier. So looking at the cross picture from EM, so this is your capillary with the RBCs inside. So this is the blood-air barrier. You can even see alveolar macrophage over here. So this is a macrophage. So the air, by the time the air gets into your bloodstream, the air is so pure. That is why from the nostrils all the way down, you realize that the nostrils will filter some dust cause particle. They even have olfactory mucosa there, which will trap some of the foreign particle. There are sinuses that will give unconducive temperature to this air that is being breathed. So by the time the air gets here, the trachea producing goblet cell producing mucus will trap excess dust or other foreign material that will be able to evade the pharynx into the larynx. You move inside, there are all mechanisms that are put in place to ensure that these things are what? Not giving problems. You don't have bacteria in there that are giving problems to the air that we breathe. So eventually, this is what you would see happening, okay? So this brings us to the end of the histology of respiratory system. If we do not have any questions, I will move. But if you have questions, let us ask. Yes, Richmond.
Sir, please, you said before the air gets to the alveoli, it's pure. So can I say only that smoking?
I can't hear you, Richmond.
Sir,
The
please, that's my
network is so poor.
So then I'll type it.
Okay, then quickly type it. Any other question? Any other question? Yeah, there is a question. So let's listen to the question. Okay, you can leave that and come and ask the question.
And the respiratory
Talk
diverticulus.
louder so that you can.
Yeah, I want to ask about the respiratory diverticulus. How does it have connection with the embryology of the respiratory system?
Okay, before I even answer your question, respiratory diverticulus, do you understand it first? They want to know what respiratory diverticulus is.
Like where the most of the epithelium and glands of the structure are being developed.
Okay, so he has explained respiratory diverticulus for you. So what happens is that now, when you are having those demarcations, differentiations, okay, as you move from this histogenesis over here, oh, why is the thing not moving back? So before this is, I'm actually looking at the blood-air barrier. That is the thing I was concerned on over here. But when you go into, for instance, from the trachea region, it's a whole lot of what signaling that comes in, where you have the differentials of, so for instance, when you come here, even before here, I was trying to explain how the simple cuboidal, okay, eventually changes into the simple squamous. It's the same thing that happens, okay? It's a whole lot. You don't study much of what embryology. That's why some of the things I just cut it out. Because if you want to do respiratory embryology, it will take us the whole semester. Okay, so for now, all we need to know is that these are the cells that are seen, these are the layers, and then this is what we are expected to know. Any other question? Hey, my time is even up. So if we finish, okay, let me look at Richmond's question. Sir, please, you said before the air gets to the alveoli, it is pure. Can I say smoking won't affect the respiratory system? Now, if you are saying it won't, because we said it is pure, smoke is a minute component of air, okay? If you do the first smoking today, you are free. But as you intensify it, it begins to build up. It begins to build up. It begins to build up, thereby destroying the whole thing. So it's not like at the first time of smoke, you are going to be affected. No. But subsequent, you remember that too much of everything is bad. So the build-up is what is going to cause, because if you are smoking and the particles are being drained by the respiratory tissue, the amount you take, you may not have the right amount of mucus and things to take them out. Then they block up, they build up in the respiratory mucosa, and then they cause havoc. So that is what happens. Yes, the blood gas is the same as the blood-air barrier. Okay, so if I'm able to come back early, we may have some 1 hour from 1 to 2. If I don't come back early, then that means we would have to look for another time for digestive histology, because we need to do digestive histology today. Thank you very much and have a wonderful day. So make sure you do your discussion on whatever platform you have concerning the time. Let me get a feedback. I mean the main feedback from the HOD, not your feedback. You are going to plead for maintenance of the time. but the HOD will give the final verdict. And that must also be known to the dean. I don't want to be seen as anything over here. Thank you very much and have a wonderful day.